Welcome to the pre-calculus notes on radian and degree measure, chapter 4.1. Go ahead and put your name and what period you're in your notes. So the first slide is a lot of vocabulary on angles, so we're just going to start with what looks like a coordinate plane. So we have our x-axis here and our y-axis here. So go ahead and draw that first. And then we're going to label this 0. This is where you're going to start any angle, which is what we call the initial side. Okay? And then any angle from there, when you go around, is going to finish on what's called the terminal side. Okay? Terminal, like in human bodies, means if you're terminal, you're dead. Basically, it's where it ends. Okay? And so if you're going up, or what we call counterclockwise, it's going to be a positive angle. And if you're going clockwise, it's going to be a negative angle. And the center, what we commonly think of as the origin, is called the vertex. Okay? If you go all the way around, you get back to 360 degrees, which is going to be 2 pi in radians. That means the opposite side way over here is 1 pi, which is 180 degrees. Straight up is half a pi, which is 90 degrees. And down at the bottom opposite that is going to be 3/2 pi, or 1.5 pi, which is 270 degrees. Okay? All right, so the first thing we're going to learn to do is we're going to learn to convert angle measurements, either to convert degrees to radians or to convert radians to degrees. So first, let's convert degree to radians. All we're going to do is multiply the degrees by pi radians over 180. So if we take 315 degrees, it's over here, and it looks like the one's right underneath the slash, but it's 315 under there. We're going to multiply that by pi. Oh, you can't see it. Sorry. It's over here. It's 315 here. We're going to multiply that by pi over 180. 315 and 180 both reduce to 7 over 4 if we divide by 45, which means we have 7 pi over 4 radians. Okay? We can also convert negative 140 degrees to radians by multiplying it by pi over 180 as well. 140 and 180 are both divisible by 20, and so that reduces to negative 7/9 pi in radians. Okay. All right, now we want to convert radians to degrees. To convert radians to degrees, now we're going to multiply our radians by 180 over pi. So basically the reciprocal of this. Okay. So the first one we're going to do is negative 2/3 pi. And we want to change it to degrees, so we're going to write our negative 2/3 pi times the 180 over pi. Notice that the pi's cancel. And the 180 and the 3 reduce. This obviously goes to 1, this goes to 60. And then we just multiply straight across. So negative 2 times 60 is negative 120 degrees. All right, now let's convert 3 radians to degrees, so we're going to multiply that times 180 over pi. The radians cancel, and 3 times 180 divided by the pi button in your calculator is going to give you this decimal 171.8873. If your calculator does not have a pi button, then go ahead and go to Desmos Scientific Calculator to get that answer. On the next slide, we're going to draw the angle with the given measure in standard position. That means we want to start at this initial position. And 140 degrees is going to put us over here in quadrant 2 with this green ray right here at 140 degrees. B, we're going to graph negative 220 degrees. And it ends up being this black one right here. So from here to here is roughly 180. And then about halfway up to the next one ends up being at this ending at the same spot. When they end at the same spot, it means that they're coterminal. Okay? And if you add 140 and then ignore this negative sign for a second and add it to 220, how many degrees do you get? All right, C, we're going to graph 2/3 pi. Now remember, from 0 all the way to here is 1 whole pi, so 2/3 pi is 2/3 of the way. From here to here, it's roughly right there where the purple's at. And D is -7/4 pi. Now if it was -8/4 pi, 4 would go into 8 twice. So -2 pi would be completely all the way around. -7/4 is most of the way, just not the last fourth. So basically, this pink is just cutting right through the middle of quadrant 1 and ending here at -7/4 pi. All right, we're going to find a coterminal angle of A through D. So you're going to add or subtract 360 from any numeric measurement, but if you have a pi measurement, you're going to add or subtract 2 pi. So for A, we have 140, so we're going to add 360, you get 500. For B, we've got -220 degrees, so we're going to add 360 and get 140. For C, we have 2/3 pi, so we're going to add 2 pi. We need a common denominator of 3, so we're going to multiply 2 pi times 3, which is 6 pi, 1 times 3, which is 3. Now that we have common denominators, we can add the 2 pi and the 6 pi to get 8 pi. And so the final answer is 8/3 pi. For D, we started with -7/4 pi. We're going to subtract -2 pi. Remember, you can add or subtract it. And we need common denominators again, so we're going to multiply by 4/4. So 2 pi times 4 is -8 pi, and 1 times 4 is 4. Once you have common denominators, you can subtract straight across. So -7 pi minus 8 more pi is -15 pi, and that makes the final answer -15 pi over 4. All right. So now we're going to draw some angles in standard position. So A is 70 degrees. So A is going to be in quadrant 1 over here. If this axis is 90, right, then 70 is going to be about right here. B is -150 degrees. So we're going to go the opposite direction, which would be clockwise. And from here to here would be 180. So -150 is going to be this pink ray. C is 9 pi over 4. So 8 pi over 4 would be completely all the way around. So 9/4 would just be just 1/4 more. So completely all the way around this direction. And then halfway through quadrant 1 here puts us at 9/4 pi. And then D is -6/5 pi. So that is our black. So here to here would be -1 pi. And then just a little bit more would put us at -6/5 pi. So the black ray. Let me shrink that just a little bit. There we go. All right, so this one we're looking at what is the reference angle of each, and I can't see it, so now I need to zoom in. Okay, so I'll move it across when we get there. All right, so this first one on the left, we're starting here, and we're going all the way around to 280. It's really small and hard to see. And so we want to see from the starting position, or what we call the initial position, how far is that angle back to that spot. So we're going to start with 360, subtract the 280. That means the reference angle is 80. The reference angle always needs to be positive. So even if this would be going the other direction, and you might think it should be negative, the reference angle is always going to be positive, so think of it maybe as the absolute value. Okay? All right. The second one, 570 degrees. We're lapping here, basically going around and round and round and round. Okay, so we end up right here in quadrant 3. And so the axis that it's closest to is right here, where this little green mark is at, which would make it 540. If you had 360 and then another 180, you would get to 540. So subtract 540 from 570, and you end up with a 30-degree angle right there. Okay. The third one over, we have, so that's 25 pi over 18. Okay. So we want, it's going to end us up in quadrant 2 over here, which is just past the pi, or the pi reference angle here. And so we're going to subtract pi, but again, we need common denominators. So I'm going to multiply this fraction by 18 over 18, which makes it 18 pi over 18. And when we subtract 25 pi minus 18 pi, we get 7 pi. So the reference angle there from this, just this green part, is 7 pi over 18. And let me move this over a little bit. No, over here. There we go. Okay. On the farthest right here, so we've got 23 pi over 6. We're doing laps again here. And it gets best back to this reference angle here, which is just this little pi bit, which in this case would be 4 pi. So we're going to get common denominators again. So multiply by 6 over 6. So 6 times 4 pi is 24 pi. 6 times 1 is 6. 24 pi minus 23 pi is 1 pi. And so the final answer is pi over 6.